Hello everyone! Welcome to our science class. I'm Miss Joy Q Batang and I will be your teacher for our lesson today.
Our lesson is about simulate how movements along faults generate earthquake using models. Have you ever wondered why Philippines often experience an earthquake? Well, that is because Philippines is located along the so-called Pacific Ring of Fire. It is a path along Pacific Ocean characterized by active volcanoes and earthquakes. 75% of Earth's volcanoes are in here, and 95% of earthquakes occur along this path. The abundance of volcanoes and earthquakes along the Ring of Fire is caused by the movement of plates in the area. Earthquake is considerably one of the horrifying and devastating phenomena that anyone can experience. You may also thought that Earth is steady and rock solid. However, you may have experienced that the surface of the Earth shakes and it contradicts to what we believed before. Earthquake cause destructions all over the world. No wonder why scientists are working hard to find ways to predict when the earthquake strikes. We cannot stop this natural phenomena to happen. However, we can learn about it and prepare for it. So, let us get started. When we say earthquake, it is the shaking or vibration of the ground surface in response to the sudden release of energy caused by fault movement. An earthquake happens when two blocks of the Earth's surface suddenly slip past one another. Earthquake is also associated with faults. When a fault suddenly moves, an earthquake occurs. But, do you know what a fault is? To know more about this, let us perform this activity. This activity is called a faulty setup. In performing this activity, we need the following materials. We need a sand, a ruler, sheets of paper, and 2 sheets of cardboard. First, we need to spread the sheet of paper on a table. Next, arrange the 2 cardboard sheets edge to edge. Then, pour the sand along the boundary of the 2 sheets. Using a ruler, flatten the top of the sand and make 3 parallel lines. And then, move the sheets slowly in opposite direction. Observe what happens to the lines on the sand. After performing the activity, let us try to answer the following guide questions. First, as you move the sheets, what is formed in the sand? Okay, very good. A break is formed in the sand. Next, what happens to the line? Very good. The line moved. It shifted or displaced. Now, let us take a look on the picture. Maybe you were thinking that the road is originally in one piece, but the road is no longer continuous. There is a cut or break across the road, and now it has two sections. One section has moved with respect to the other. Now, we are going to compare it on what happened in the activity earlier. Is there any similarity between the two? Based on the activity and the picture, you may have an idea in mind what a fault is by now. When we say fault, it is a fracture in the Earth's crust where one side moves relative to other. Or we can also say that along this fracture, significant movement has taken place. There are three types of fault: the normal fault, reverse fault, and strike-slip fault. In normal fault, rock layers in the Earth's crust are pulled apart, and gravity causes one section to move downward relative to the other. This fault motion is caused by tensional forces and results in extension. In reverse fault, rock layers in the Earth's crust are squeezed together and the force pushes one section upward in relation to the other. This fault motion is caused by compressional forces and results in shortening. Lastly, strike-slip fault. It forms when two rock layers on opposite sides of a fault slide past each other horizontally. This fault motion is caused by shearing forces. Now, the question is, how do faults generate earthquake? To answer this, let us perform another activity. This activity is called stick and slip. In performing this activity, we will be needing the following materials: rubber bands, scotch tape, paper clips, and two small boxes. The carton that fruit juice boxes are packaged in are perfect. First, attach the rubber band to the paper clip. Then, attach the paper clip to one end of one box. Next, place the box side by side. Tape lightly the two boxes together. Remember, do not stick the tape on the boxes too much. The tape is meant to come off. Then, put a toy house on top of the box with rubber band. Third, hold the box without the rubber band in place. With your other hand, slowly pull on the rubber band. The rubber band should be pulled forward and horizontally, not sideways, upward, or downward. After performing the activity, let us try to answer the following guide questions. First, what happens to the box attached to the rubber band? Very good. The box jolts forward. Next, what happens to the house on top of the box attached with rubber band? That's great. The house falls over. Which is fault in this setup? You are correct. The fault in this setup is located between the boundary of the two boxes. The boxes represents the ground and the boundary between them represents the fault. As the box jolts forward, this simulates the movement that occur along fault. Likewise, the release of energy from inside the earth makes the ground move. In this setup, The tape represents friction. But do you still remember what friction is? When we say friction, it is the resistance to motion of one object moving relative to another. If the tape is too sticky, it will never come off no matter how much rubber band is pulled. But since we tape it just enough for it to come off, the box jolts forward. This is how fault generates earthquake. Some scientists describe this process as stick and slip. At first, the friction across the surface of the fault holds the rocks together so they do not slip immediately when pushed sideways. However, when the stress builds up and the rocks slip suddenly, it will then release energy in the form of waves traveling in the Earth's interior, causing trembling or shaking in the Earth's surface. Based on our activities that we did earlier, we can conclude that when fault slips or moves, it generates earthquakes. And that ends our lesson for today. Did you understand it very well? If not, you may go back to the lesson presented on your module. If today's lesson is very clear to you, congratulations! You may now answer the exercises on your module. Good luck!